Hello everyone, welcome back to the class of Reservoir Simulation. Today we are going to talk about how to start using the Eclipse Office software. Well, first of all, you have to look at the icon, this Eclipse launcher icon that you see here. This icon will appear on your desktop and you can double click this icon and you will have the window here to and the Eclipse simulation software launcher will open. Now we have here number of options we have here. We have Eclipse, we have E300, we have FrontSim, we have Petrel, FlowGrid, Office, FlowViz, Skull, Simp Out, PVTI, Sudo, Manuals, VFPI, Graph, Grid, and so on. So we have too many options to play with, and in this tutorials we will talk about how to use this E100 Eclipse E300 and the manuals and how to see the results. Now in the previous lecture we have some file, we talked about the data files and how to prepare the data file. Today we'll talk about how we can use this software. So first of all, after you start this, let's see how we can the data file that we have, how we can run it. For example, we have this data file, we talked about it in the last one in much details. So we have this data file and we want to run this data file, this one we want to run this data files. So how we can run these data files? So once you have your Eclipse ready, so remember we in the previous lecture we talked about we have two kinds of simulation. One is the black hole simulation, other one is compositional simulation. So today right now these files are compositional simulation. As you can see that they have uh, their critical properties. Let me show you. This one is the yes. So here you can see that in the data file their critical names are shown here: C1, C3, C6, C10, C15 and C12, and critical temperature, critical pressure, critical Z factor, molecular weight, eccentric factor and BIC factor and stone model. So all these are related with the compositional one. While in the black oil simulation, there's nothing like this. In the black oil simulation, we just say that we have oil, water and gas, dissolved gas, and we don't talk about the any critical properties. Here you don't see any critical properties. Here we have PVT data, but we don't have any compositional C1, C2, C3 and so on, or C5 as we discussed before. So let's see how we can run these files in the Eclipse launcher. So once you have Eclipse open in your desktop, click on E300. The Eclipse first one, this one is for the black oil model. This one is for the black oil model and this one is for compositional model. So right now we have both files. This is the black oil file and this one is the simulation compositional file. So we talk about, let's run the compositional one and see how it works. So we click on E300. Now our data is available here, users, this my folder name Muhammad Ali, desktop, Eclipse. This is the data file where exactly the data file is. So I will copy this one and I will try to reach it here from the C. Go to the users, Muhammad Ali, then we have the folder called Eclipse here. In the desktop, Eclipse, and Eclipse I have these two files, see, miscible and vec. So I'm going to run the SPD Vector. So let it run. After you run it, double click it, the window will appear. You see now that this now simulation is running. You see this black one. So now here you see this is the E300 compositional data set, and this simulation software is simulation running. Okay, here you see here it is running the data simulation for whatever period you have settled here. Now when you finish it, you see there are no errors. When there are errors, you cannot go to the results unless you solve the errors. Now errors could be in programming, like you saw in Python, a small dot could cause the error. So now small slash in the data file can do the error. So we don't want any problem or error here. Here these errors, this is not needed. Here is 0. So now we can see the results. But if there is an error come, means there is a problem in the data file, and then you need to correct it. So let's see how we can view the result. Now we run the data file, and now we can view the results. Let's see how we can do that. So now I will close this one. I don't need this. Once you close it, you see lots of data files are generated here. The results are stored in this SMPEG file. The results, we call it here. This file is the one, this one. This file is the one which has the result. So now we have to open this file, and in order to open this file, what we have to do, we have to go to the C folder where our Eclipse office is. C folder where we have our Eclipse office is. We go to the 2009, we go to the bin, we go to the PC. So here we have all the applications of Eclipse office installed in C, ECL 2009 bin and PC. So I will directly go to the office. I need to open the office. So I will go to open the office application. Or let me check if here's the office. Now you see the license working is fine. It expiry is 2030. So it works here. And we need to go to the results section. But let me check if we have directly the results section. We don't have the results section directly. So here you have to go to the results. Okay. Once you go to the results, this will open. Okay. Once this will open, you go to the file, go to the open, go to summary, load all vectors. Once you load all vectors, you see the SPE5 vec SMPEG is appears. You have to browse the file wherever your data file was. You have to go there. My data file was on desktop in Eclipse folder, so I double click on it. Now once you double click on it, you have this one FGOR. These are your results here. See FGOR versus time, FOPR versus time, FOPT versus time, field water cut, and field water protection rate. Okay. Now these are the files. Now in the reservoir simulation study, you have the data file. You run it. After you run it, you go to the results and you look at your results. Field gas oil ratio. Now here you can read it. Right. This X is field gas oil ratio. This X is time is mentioned here, and Y is the field gas oil ratio. Okay, how much is the gas oil ratio? This is the field oil production rate. This is time versus field oil production rate. Okay. So now you can see, you can read it that initially in the first, if we change this to font show title, we talk about days range. So limit range 365. These are the days from 0 to 6000 we have, and the gap is 1000 days. Here you can see, you can change it always. Plots, fonts, tables, and so on. So now you can see that in the first 400 days, the rate is around 12,000 barrels per day. Okay, then the rate decline, and then it becomes 6,200 or 400 or 300. But the point here is around 6,400, as you can see here, is mentioned here. As mentioned here, you can see. And the good, now you can observe that the rate is declining and then increasing, declining, then increasing. So it is in a cyclic form, means increasing, declining, increasing, declining, increasing, declining, and then in the end, here the simulation stops. This is the total oil production. You can see that how much oil they have produced, around 3 into 10 power So here you can see that our value is here. It is around 28 million barrels we can produce in the time of 6,000 days, which is around 20 years. You can see here that we can produce. Then this is the field water cut. You see that in the beginning of nearby 4,800 days, there was no. Here, if we look at the value 4,747, there was no water production, and then the water production increased and then it declined. And then we have the field water production rate. Again, you can see till this time 4,700 days there was no water production, then the water production rate was increasing. Now here we have only 5 1, but if you want to add more you have to play with the data file. For example, the data file, it was on our data file was here, all the results were here. So the data file that we run was this one. So now if you go to the summary section here, these are the, remember, these are the results. If you see that we had FGOR, FWCT, FOPR, FOPT, FWPR. FGOR, FOPT, FOPR, FOPT, FWCT, FWPR. So there were 5, but we want more. For example, we want FGIR, FGPT, FGPR. And we have, if we don't have FOPR, so I want to put FOPR. So what I will do now, I've added more. I will save this file, close it, and I will go back to the Eclipse, go to the Eclipse, run the data file again. Now my file is run, so I will now close it again, and now go back to the results. Go back to the results. I will open summary, load all vectors. Again I will run the file. Now this was the previous one, now is the real one. Now you will see that we have more. Now you see in the previous one we had only 5, 1 2 3 4 5, but now in the new file we added more. We put the field gas production. So this is the field gas production total, field gas injection rate. This is the field gas injection, because we are talking about the water alternating gas injection, and water is injected for some time, then we close it, then we inject the gas. So now from 1,100 days uh, the gas is injected, okay, then till the 1,400 days. So for 1 year we inject the gas, so for 1 year we inject the water. So this is the field oil production total, and the field gas production total is this one. Gas was we were producing throughout, and then we end the price. This is the field gas oil ratio. So you can put the results, discuss and analyze the result. You have to do the history match of the results also, especially the field products oil production rate, that they match with the original one, and so on. Now I will show you more functions of this software that you can use. Yes. Now first of all you have to make file, open project. No, we will make a new project here. New project. Let's say project is simulation. So we have made a project called simulation. First of all we have to import our case. So there is a case and there is an import option. We go to the import and we go to the desktop. In desktop I have folder Eclipse. There I have the SP file. Well, I will import the file. Once I import the file, all the sections, we said that in the data file there are many sections. We have run spec, PVT, skull, initialization, region, schedule, summary, and all those regions. These are just the case name and basic definition. Run is not going to work from here, but this is the data that we have. Now I want to look at the grids. So I will go to the grids. There's a grid view. I will run from keywords. Click on yes, run. So we will go to the 3D one. So here is it. Now this is our model that we are using. We have one injection well in this corner. We have one injection well in this production corner. So you can look at the data, and of course you have values here. You can change. You can put more grid lines. Apply. So these are now. So we have how many blocks? we say we have to discretize the block. So look at the discretization: 1 2 3 4 5 6 7. We have 7 blocks here. So 1 2 3 4 5 6 7. So and well, let's look at the data file again and see do they match or not. So this is our data file. Look at this one: 7 7 and 3, and we have 3 layers here: 1 2 3 4 5 6 7. And we said we have one injection well, one production well. Now the question comes here that how we can put the location here. I mean, well, production well is here, why not here, or why not here? So we can change the location of the well and so on. That's not a problem. And then we have more information here about this. We can do more. This right now is porosity, and porosity is all same, but you can change it to others also. This is the one. You want to check the permeability, so this is the permeability of X, Y and Z is 3 layers has different, so you can check all the properties here. These are the cells. This is porosity. Here you can see all the properties that we can put here. So that's how it is. So this tutorial actually tells you how to run the Eclipse office and how to run the data file that you have prepared, and how to run the office and how to get the results out of it. And then you have to discuss those results based on your hand. That's where the job of reservoir simulation engineer comes, because they have to discuss the results, that how the results are obtained and how they are discussed. So here it is, and this is the time steps that we are talking about. Okay. For the simulation one, uh, and if you want to look at it in a 2D, you can also look at it in 2D. These are the 3 layer: layer 1, layer 2, layer 3, and these are the X and Y. This is Y, this is X of the reservoir discretization, and so on. You can do it also. For example, now you want to look at the other properties also. For example, you close this one, you have PVT data. So you have lots of PVT data given. You go to the grid view, sorry, section and keywords. So you see here we have a pressure, we have a formation volume factor, we have the viscosity, all the data is given. Fluid densities, this is 2.4. So all the data is given here. Okay, you look at the rock table. These are the rock data. Then you have other data: standard condition mentioned 16.5. How many components you have is discussed here. And if you have any region, there are no regions. If you have any vertical lift profile tables, and so on. So this is the data that you can put. Then you have the skull data. In skull data, again you go to the section and look at the keywords, and it tells it's a relative permeability data. We have to put the water saturation, relative permeability of water, and this is the capillary pressure data that you have. Then you have the gas saturation, relative permeability of gas, and critical capillary pressure. You see we have water, gas and oil, 3 of them. Oil saturation, relative permeability of oil in respect of water, and relative permeability of oil, water and gas, 3 phase. Here we have all the data given in the saturation table. You can always change it from here also, but we don't use this format. We go directly to the data files and we work from there. Then we have many options here. We can apply the hysteresis and so on. Then we have the initializations. It talks about where is the water oil contact, where is the oil water cap, where is the gas oil GOC there. Uh, so we have all the equilibration data here in this one. This is the aquifer data, if you, because there is no aquifer here special, and so on. So after you have this data, you have then regions. We do have no regions in this one, so we directly go to the schedule. In schedule, remember that how many wells we had. You have to this is the time step. Your simulation is going to run from 1 January 1990 till 2012. The simulation will run for many years, till around 22 years, and these are the well specifications, like how many wells you have. The well specification means you have well 1, production well, field, This is their location, I7 and J7. This is the depth of the well, and this is the PVT properties, and these are the separator condition. This is the connection data, exactly from which layer you are producing. So you have to mention the upper and lower K. So we are producing from the layer 3 here. You have to mention as well bore ID, which is 0.5. So the well data, connection data, and so on. This is the how much is the production rate you are going to put. Well is open or closed here. So you have to put this data here. Then this is the group data that we have. So once you have this, you do summary as we discussed what you want to see, what is your objective. You want to check the oil production or you want to check the water production. So what is your objective? Based on that, you add more keywords as we discussed earlier, and so on. So after you finish this, you run actually, but run here is not going to work. You have to run the file. If you run from here, it will fail actually. So because of the license error, so you have to run the way I showed you initially how to run the data file. It's going to see, you see here failed. It's because of the crack. So you have to go to the original file and see how it works. Remember, what we are doing is a totally academic purpose. There's no other purpose that we have here. Sometimes you have error, so you can look at the current cases and open the PRT file and see what kind of error it had. It can tell you also. Now, usually this is needed. This is the total. So what graph you want to make? If let's say you want to make time versus fuel oil gas ratio. So generate report. You can generate the report and go to the output. You see here's the report. If you want to plot it, it will plot for you. And if you want to look at the data, how much it created in time, days, it can tell you here. This is the original data file you can create. The reports it can generate for you. This is the table. Time. In 365 days, this was the gas oil ratio. And so all this data it has generated for you here. So this was the general introduction of the software and how to use the software. I hope you enjoyed it and you will learn and follow the steps to use this one. So have a nice day.